Here are the 10 steps to successfully recharge R454B. 1. Deep system evacuation. Perform a deep vacuum on the system until a level of 500 microns is reached. This level is essential to ensure the complete elimination of moisture and other non-condensable gases, like air, which can chemically react with the refrigerant and oil, forming acids and sludge detrimental to the compressor. Use a vacuum pump with a precise digital vacuum gauge for accurate measurement. 2. Leak test. Vacuum decay test once 500 microns is reached. Close the vacuum gauge or pressure manifold, isolate the system from the vacuum pump, and let it sit for a minimum of 20 to 30 minutes. Carefully observe the vacuum gauge. 3. If the vacuum remains stable or increases very slowly, e.g., not exceeding 500 microns, it indicates that the system is free of leaks and residual moisture. If the vacuum is lost rapidly, it is an unequivocal sign of a leak in the system. It is imperative to locate and correct the leak before proceeding with refrigerant charging. 4. R454B, being a slightly flammable A2L refrigerant, requires specific precautions due to its slight flammability. Always work in a well-ventilated area to prevent the accumulation of refrigerant vapors. Remove all possible ignition sources from the work area. This includes open flames, electrical sparks, hot surfaces, and non-explosion proof tools. 5. R454B is a zeotropic refrigerant mixture, which means its components have different boiling points. To maintain the design composition and performance of the mixture, R454B must always be charged in the liquid phase. Gently shake the cylinder before use to ensure a homogeneous mixture. For a single outlet cylinder, invert it 180 degrees to ensure the refrigerant exits as a liquid. For cylinders with 2 valves, use the designated liquid phase outlet, usually marked in red or with the word liquid. 6. Precision in the amount of refrigerant charged is fundamental for the correct operation and efficiency of the equipment. Place the R454B cylinder on a precision electronic scale and tare the weight. This will allow you to monitor the exact amount of refrigerant being transferred into the system. Consult the nameplate or data plate of the air conditioning equipment to determine the required amount of R454B refrigerant. 7. Initial charge with equipment off. If using a charging machine, with the equipment off, program the machine to inject 100% of the manufacturer-specified refrigerant charge by weight. If charging from a cylinder, with the equipment off, start charging and add at least 70% of the total required charge. This passive charging method takes advantage of the pressure difference between the cylinder and the evacuated system, allowing a significant amount of liquid refrigerant to safely enter without risk to the compressor. 8. Final charge with equipment running. Equipment startup. Once the initial charge is complete, turn on the equipment in cooling mode so the compressor begins to draw in the refrigerant. Very slowly open the manifold valve to allow for minimal and controlled refrigerant entry. A recommended technique is to recharge intermittently, opening and closing the valve every few seconds. This allows the liquid refrigerant to vaporize in the suction line before reaching the compressor, preventing liquid slugging, which can severely damage the compressor's valves and pistons. Continue this process until the scale indicates that the total refrigerant weight required by the equipment has been reached. 9. Approximate charge by pressure. Charge the initial amount of refrigerant in the same way as described in step 7. Then turn on the equipment and add refrigerant in small, intermittent quantities until 117 pounds per square inch (psi) is reached on the manifold gauge. 10. Electrical consumption monitoring. Clamp ammeter. Measure the current consumption, amperage, of the compressor on the power cables. Verify that the measured amperage does not exceed the RLA value indicated on the equipment's nameplate. Excessive amperage can indicate a refrigerant overcharge, which increases compressor strain and energy consumption.